Okay, so adding another podcast here on the impact of the southern annular mode on monsoon extremes. The extremes here are looked at in a decadal phase, so which is important because there is a persistent decadal, multi-decadal mode in the monsoon and many other things in the region, but typically people are not always very careful in distinguishing the secular trends or multi-decadal modes from climate change impacts or anthropogenic trends. For example, the IPCC AR6 says that there is low confidence in attributing monsoon extremes to human impacts, and attribution studies are not that many, but that doesn't stop people from saying repeatedly that we are having extremes because of climate change. Does it matter? Yes, it does, because as scientists we need to have credibility in the end. Okay, so that's just my philosophy. So we already looked at the impact of northern high latitudes on droughts during late monsoon season and extreme events during the late monsoon season. You would expect that the southern high latitudes will also have an impact, especially because the Southern Ocean is a channel and you have these kinds of features where you have the subtropical front, the subantarctic front, and the polar front with the southerly westerly winds, SWW, and you expect this thing to move like an accordion in and out, which is what happens during the so-called annular mode. So this is the positive southern annular mode and the negative southern annular mode, and you can see the tremendous difference between where the subtropical front goes in the two cases and how far the southerly westerly winds extend in the two phases. SWW and SDF contract in the positive as SAM. It's referred to as SAM, southern annular mode. Increased wind strength, winds contract poleward, lower anomalous air pressure over Antarctica, Patagonia warms, decreased precipitation, glaciers recede, Antarctic Peninsula warms, increased CDW, upwelling. So this is the upwelling region into the inside where you have the central deep water upwelling around West Antarctica and Antarctic Peninsula. Okay, SWW and SDF expand in the negative SAM. SWW decreased strength, higher anomalous air pressure over Antarctica. Patagonia cools, increased precipitation, glaciers advance. Antarctic Peninsula cools, decreased CDW upwelling, and in West Antarctica and Antarctic Peninsula. So obviously the Ekman divergence shifts, and the upwelling shifts. The strength of the upwelling changes as well. How does it affect the Indian monsoon? You can imagine that when this happens, here is the Pacific sector and here is the Antarctic sector. No, here is the Indian sector. So sorry, here is the this should be the Pacific and this should be the Atlantic. This is the Indian Ocean sector. So you expect that when such large changes happen to the subtropical front, it's going to have an impact all the way to the northern Indian Ocean across the equator. So they start by looking at the rainfall over this region, and here is the rainfall in millimeters per day as anomalies, and then they draw a line here of 2 standard deviations, and you look at the in this figure here, you're looking at time series of extreme rainfall events which exceed 2 standard deviations with 11-year running mean. So there are decades where the extremes are higher, there are decades where they are lower. Is it an anthropogenic trend? Not always easy to say, because you need a much longer time series to be looked at to eliminate natural decadal variability as reason. But one has to be also careful because global warming can modulate natural variability. So the question is, are the extremes lasting longer than before in their phase of the decadal oscillation? So these are complicated questions. Here we are looking at SAM index changing from a negative to a positive in the 1990s and has stayed positive into the 2010s. This goes to 2015, and the monsoon decadal variability also has moved into the positive. There is lots of debate about this, about which data set is correct and which is not, and the box taken here is large, so it's not just focusing on the Indian subcontinent, it's also including the Bay of Bengal, which has lots of rain. So one has to be careful about that as well when we say extremes over the Indian region. So these are the regression patterns of mean sea level pressure. So we are having in the 1990s to the 2000s lower sea level pressure, which would give you a cyclonic circulation in terms of potential vorticity. It loads up the moisture at both the low level 850 hectopascal and 500 hectopascal. This is the 121-month running mean of the SAM index that is being regressed. Mid-tropospheric humidity loading typically corresponds to convection and conditions for rain. And here is the regression pattern of sea surface temperature. You can see the entire northern Indian Ocean is warmer in this phase in the 1990s onwards. This is looking at low-level clouds, which are increased over the northern Indian Ocean. Okay, so take it for what it is. And in sea we are looking at net heat flux. So there is loss of heat flux, which you have to be careful about the sign. Warm SSTs can increase latent heat loss, which corresponds to the moisture loading as well. Where is the moisture? This is the moisture, specific humidity. So because the convention can be heat flux is positive into the ocean or positive out of the ocean, so you have to be always careful and always look for consistency. Okay, warmer temperatures, larger heat loss in general, unless the warming itself is controlled by the atmosphere and weaker circulation, for example, reducing the latent heat flux and increasing the sea surface temperatures. Okay. D is the surface air temperature with 121-month running mean of SAM. So both, if ocean is warm and atmosphere is warm, that means ocean is giving latent heat flux to the atmosphere, so that is the latent heat loss. Okay, so always follow the logical steps. Finally, what is actually happening in terms of circulation? So here is the time series of the meridional wind speed anomaly at 850 hectopascal with 121 month running mean averaged over the equatorial Indian Ocean. So they're arguing for a cross-equatorial southerly flow from the south to the north, which is consistent with the thermal contrast created by the decadal change. But one has to be also careful because the arguments made for extreme papers that look at more widespread extremes is that warming of the Arabian Sea is supplying more moisture to feed the extremes here, because warming on land doesn't always correspond to extremes on land, because warming can create instabilities, but to produce especially extreme rain, you need moisture, and moisture typically comes from the oceans. So the Cole et al. Paper from 2017, I think, argues that the Arabian Sea is supplying majority of the moisture to the widespread extremes over the core monsoon zone. And these warming patterns are also significant. In general, you always find that warming over the Bay of Bengal is not as strong as the warming over the Arabian Sea, and it's been explained in various ways. For example, Roxy Matthew Cole argues that this may be related to El Nino low frequency rectification, which has to be verified, I suppose. Okay, so the circulation changes here are argued based on the land-sea thermal contrasts. So you can see here the meridional winds in color being positive, so across the equator, and the wind vectors that are regressed again with the 121-month running mean of SAM shows the changes in the subtropics and tropics and cross-equatorial flow here. This is their argument to say that the decadal increase in monsoon extremes, larger than 2 standard deviations, in the 90s and the 2000s is related to SAM. But one cannot ignore these things, which we have used before as connections to mid-latitudes. So late season extremes were explained by mid-latitude extremes related to Arctic sea ice loss, especially Kara-Sea. And the late season droughts were related to North Atlantic sea surface temperature and vorticity anomalies. So is there a misinterpretation, or are the northern and southern hemisphere forcing really independent of each other? Those kinds of questions are not answered here, but one could argue that these are reminiscent of the Rossby wave patterns that we were talking about before. The main point I want to leave you with is that there is evidence for southern ocean southern hemisphere forcing of the monsoon extremes as well, and the processes always come down to land-ocean thermal contrast. There is also vertical motion that is associated with these anomalies of SAM that the paper argues for. So vertical motions, moisture loading are consistent with each other, and convection and extreme rainfall are consistent with those, and SST warming as well. Okay, so that's just an example of southern hemisphere forcing of monsoon extremes.